morning, everybody. Hopefully everyone is alright. Hopefully you're doing well. It is the Wednesday, it's the middle of the week. So, first thing, a little quick update is that for the moment, at least, I've had to disable live chat. I'm looking to see if I can get it re-enabled at some point, but for the moment at least I've had to turn that off. If you are one of the students at school, you can still feel free to email me at any point and I will respond to those emails if it's about stuff that's been on this stream or any of the streams that we've done so far. I would still recommend you having some pen and paper with you always, because then you can have a go at some of the things that we do. You can get some notes down, you can help get yourself some little examples so that you can look back on them as well. And yeah, everything else will remain kind of as normal. It's just that live chat for the moment, that will have to be turned off for the moment at least. Okay. And for today we're going to be looking a little bit more at circles. Okay, we looked at how to find the area of a circle in our last video. It was one of the formulas which we said that we would have to remember, and one of the ones that we're going to have to revisit over and over. Make sure that we know how to use it and how to use it properly. But what we're going to be looking at today is not just a circle by itself. We're going to be looking at how we find the area of things which involve circles. So we could be thinking about like a circle on top of another shape. We could be thinking about semicircles or quarter circles or three-quarter circles, slotted in with other shapes, things like that. And so knowing how to find the areas of all of our shapes, not just the ones which we looked at last time, will become useful. Okay. So for the first thing for us to think about is is just to remember the formula. Okay. So what is that area of a circle formula? How are we doing in looking to remember that? So the formula itself, just pi times by radius squared. Pi is a number. It's 3.14 if we're looking for two decimal places. Radius is the part of our circle which goes from the center of the circle to the edge. And we will need to look really carefully today at whether the measurement that we're given goes all the way across the circle bit, in which case it's a diameter, or whether it goes halfway across the circle, in which case it would be a radius. And we're also going to we also will have to check to make sure how much of a circle we've got. We're going to have to look out for quite a few different things today, okay? But there's that formula that we're going to need, that we're going to have to look to do our best to remember. And the first thing for us to have a look at and to think about and check is, first of all, do we know how to work with a half circle, semicircle, a quarter circle, three-quarters of a circle? Okay. And the key with like any part of a circle, whether you've got a half or three-quarters or whatever, is to think about what the area of the full circle would be. Okay. So for the two examples that we've got here, okay, we've got a semicircle. So the first one on the left, we've got a semicircle which goes a distance all the way across for 20 centimeters. Okay. Now, we've got to remember that we want pi times radius squared for the area of a full circle. Okay. So if I were to find out the area of the full circle for that one on the left, I would have to find the area of pi times 10 squared. Okay, the distance goes all the way across, it's the diameter. We want the radius. We need to half that. Okay, so if we've got pi times 10 squared, just for a note, 10 is 20 divided by 2. And so then pi times 100. And if you remember back to how we could write our answers, we can either write them a lazy way or by using our calculator. I'm going to go for our lazy way, writing it in terms of pi. So that would just be 100 pi. That is the full circle. Okay, that would be the circle that goes all the way around. I don't want a full circle, I want half of a circle. So for the semicircle, I want to do 100 pi divided by 2. Because that will tell me half of the full circle's area, which is the area that I want. Now, for the moment, we can ignore the pi and we can just think, what is 100 divided by 2? And that is 50. So my answer would be 50 pi. Come on. There we go. No. If we're going to play up, I'm going to fix it. There we go. So that would be our area for our semicircle. Okay, it would be 50 times pi, or 50 pi. Looking at our units, though, we do have units. It's in centimeters. Area, we measure in our unit squared. Okay. For our second example, okay, this time we've got a quarter of a circle, okay? And the information that we've been given here looks like it would go from, if we imagine stretching our circle out, like so that we could see the full circle, it would go around, you know, something very badly like this. Okay, so that distance that we've currently got is going to be half of the distance overall. So that 4 meters that we've got there, that is actually our radius. Okay. So our radius is 4 meters. I want to first find out the area of the full circle. So the area of the full circle would be pi times radius squared, or pi times 4 squared. 4 squared is 16, so that would be 16 pi. But I don't want the area of a full circle. Okay, we don't want that at all. What we actually want is just quarter of it. So I want a quarter of 16 pi. And that's the same as us just looking at what is a quarter of 16 and then putting pi on the end. So a quarter of 16 is the same as thinking 16 divided by 4, which is 4. And our units were meters, so meters squared for our area. Okay, and just to, as a kind of, for argument's sake, what if we had like 3/4 of a circle? Okay, and the radius was 4 meters. So we would still do exactly the same. We would still think pi times radius squared. We would still work out the area, which is exactly the same as the one we had before. But now we would have to do 3/4 of 16 pi. Now, this is where a little bit of fractions work does come in, okay? And the more that you get about fractions will help you a little bit with the rest of the circle stuff. To find a fraction of something, we divide by our denominator, to get it into quarters, and then times by our numerator to find out what 3/4 would be. So 16 divided by our denominator, 16 divided by 4 is 4, times by our numerator, so 4 times 3 is 12. We get an answer of 12 pi meters squared. Okay, and it will be really important for us to be able to work with these half circles, quarter circles, 3/4 circles, anything like that, if we're going to be looking at compound shapes and working with circles merged with other shapes. Okay. So we're going to look at some of those combinations now. Okay, I'm going to take us through the one on the left so that you guys can have a go at the one on the right. Okay, and we got to think about what it is that we did when we were working with compound rectangles and triangles and things like that. So what did we do when we were working with those kinds of things? We looked to split our shapes up. Okay. So for the shape that I've got here, I'm going to split it up into a rectangle and that semicircle. The rectangle, we know how to find the area of. The semicircle, we had a look at how to find the area of. That was our first example. Now, the 10 centimeters that was written at the bottom here, that is the same as the 10 centimeters that goes across our semicircle here. Okay, so that distance does not change, so we can say that the 10 centimeters there is the same as the 10 centimeters along here. Okay, you can see that, it's the same width going across. So then I just need to find the area of each separate shape and then put them together. So the area of the rectangle is just 8 times 10. The area of the semicircle, we do pi times radius squared, the area of the full circle, and then divide it by 2. The 10 is the distance that goes all the way across, that's our diameter. So we're going to want to look at pi times 5 squared, 5 being the radius, half of our diameter. And then find out that answer, 25 pi, divide it by 2. Is as a decimal answer without pi, we would get 39.3. Okay. With the pi there, it would be 12.5 pi. Okay. So I want you to have a look at the one that's on the right. Okay, and I want you to have a think about how can I find the area of that shape? Okay, how can I split it up? What's the area of some of the parts? And then see if you can add them all together. I'm going to give you about 4 minutes to have a think about that. All right, so let's have a think of a process for this. We still want to cut the shape up. So then we're going to take the area of our rectangle, which is 11 centimeters by 10 centimeters. And then we're going to have to look at the area of the quarter circle. Now, here, it looks though the circle goes halfway across the top. So you could look to say, okay, the radius is 5.5, but actually we're told a measurement for the radius at the top. Okay, the measurement that we've been given is that it's 5 centimeters. So what we should actually look to do is to look to use this measurement up here, okay, rather than thinking about the distance going halfway across. Okay, it may look like it does, but we can't assume that that diagram is drawn correctly. Okay, we have to actually take the measurements that we are told. Okay, so the radius of that circle is 5 centimeters. So I've got pi times 5 squared, which will give me the area of the full circle. I've then got that answer divided by 4 to make it a quarter of a circle, and then add the two numbers together to give us the area of the whole shape. Okay, and there we go. Okay, so hopefully these two examples can give you at least a flavour of how you should look to go around looking these solving these kinds of problems. Okay, now on this slide here, we've got 6 different shapes, and what we're looking to do is we're looking to try and find the area for these shapes. Okay, now one thing that I would look carefully at is the measurements that you are given and where would you look to split the shape up. Okay, some of these are more difficult than others. Okay, but if you split your shape up correctly, you can make these problems a little bit easier. Okay. Number 4 is probably one of the most tricky. Okay. And when you get further along, you may have to split up your shape into more than just 2 parts. Okay. Now, because for this video I've not got the live chat stuff with us, what I'm going to do is I'm going to give you a moment to pause the video here so that you can have a go at those questions for maybe 10 minutes or so. Okay, maybe a bit longer if you want to pursue some of the harder questions as well. Okay, so I'm going to give you a short moment just to pause the video to have a go at some of these questions, and feel free to rewind and look at the examples as well to help you. Okay, so hopefully at this point if you have paused it, you've had a go at some of the questions, you're ready to know how you did. Okay, and so answers will be coming up in 4, 3, 2, 1. Okay, now all of those answers should have units attached to them. Okay, all of the measurements here are written in centimeters, so all of our units for all of our areas should be written as centimeters squared. Okay, these are all written to 1 decimal place. Okay, so there is a little bit of rounding involved as well. And for all of these, because we're dealing with circles, we're generally looking to use our calculator and use the pi button on our calculator, either using the change button or the S to D button to get our decimal answers as well. Okay. And as I said, normally I kind of at this point ask how's everyone doing, all those kinds of things. For the moment, what we'll say is, if you got a question about what we've gone through here, feel free to email me if you are one of the students that I work with. And if you want to try out a little bit more of this, look on Hegarty to some of the tasks that you have been set or are set within the email that I sent out. And between that, there should be a lot of stuff for you to practice. Okay, but I'm gonna leave it there because that's a decent place for us to leave it for the moment. And I will see everybody in our next video, which will be on Friday. Ta-ra.